So now I know you've all heard that waves travel at different speeds in different media, typically faster in denser media. So for example, sound travels faster in water than in air. So when the flux depends on the density of the medium, this produces a nonlinearity in the advection PDE. So we're going to suppose that flux is now actually a function of u itself. And then when we look at the conservation law, we have that the partial of u with respect to t plus the partial of phi of u with respect to x is going to be equal to 0. And so maybe just for emphasis, I'll put some more parentheses on there. So when we do that partial with respect to x, what happens? Let's unpack it. So we're going to get phi prime of u times u sub x is equal to 0. And so then we can take this as ut plus c of u ux is equal to 0, where the wave speed now is phi prime of u. And the upshot is that we can just work with this new advection equation where the speed here now depends on the density. All right. So then, and I guess it's probably worth noticing that there's a standard assumption that goes with this, and that is that c prime of u is positive, with the idea that the denser the wave, the faster the wave travels through it. So let's see. So suppose we want to solve the initial value problem of ut plus cu ux equals 0, with ux0 being given by some function phi. And so this will be for any real value of x and for t positive. All right, so we will take the characteristic curves to be integral curves of dx dt equals c of u in immediate alignment with what we had before. Okay, so then if we look along the characteristic curve x of t, what's going to happen? Well, if we look at the total derivative of u, and so now its x depends on t, and it still has its t. So we're going to need to do a chain rule now. So we have u sub x, x of t times x with respect to t, plus u sub t x of t times the derivative of t with respect to t, which is just 1. So then let's see. So this is going to be u sub x times, and then if we look at our derivative of x with respect to t, this is actually equal to c of u now. So this is times c of u. And then this is plus u of t. And if you look at this last equation that we have, so cu times u sub x plus ut Well, that was apparently our given PDE, so that should be equal to 0. And so from the very beginning to the very end, what we've just shown is that the total derivative of u along the characteristic curve is equal to 0. So what that's telling us then is that density will be constant along the characteristic curve, which is exactly what we want for using the method of characteristics. And so what is the characteristic curve? Well, it's going to be a straight line. And to see this, let's see. Well, if we look at the second derivative of x, then this is going to be d dt of, and then x prime over t we just saw previously was our c of u function. So this is going to be c prime of u times du dt by chain rule. But we just saw in a step just above that this derivative is equal to 0. So the whole thing is equal to 0. So that tells you that x has no curvature. Okay, so we've got our, and that's x of t, our characteristic curve. So our characteristic curve is a straight line. And the speed of the characteristic through the coordinate x comma t, so this is going to be, again, dx dt. And so this is c of u of x of t t. And so then this is going to be, and let's just draw a little figure here to see what's going on. If we've got so some axes like this, so here's x and here's t, and if we're looking at some location xt right here, then we're going to back this up to time 0, and so this will be c0 for some value of c back on the starting line. So this is going to be c of u c0. And if we go back to our initial condition, then it turns out that that is going to give us c of phi of xi. Okay, and so from this equation here, dx dt equals c phi of xi, then we see that x is going to be the same thing times t plus xi, just by integrating. Okay, so then this equation determines our xi function as a function of x and t implicitly. And then In this case, u, our solution, will just be phi of xi for xi determined by this implicit equation.